Now we want to get the idea about what is quadratic surfaces. Before this, in week 6 video, you have learned linear equation and quadratic equation. You need to know how to plot two kind of equations. So here, there are a special class of equation that is involved linear and quadratic form of variables. Means that the equation involve x, y, z, x square, y square, and z square. This kind of variable can be related or can be formed equation, and we call it as quadratic surfaces. And there are many types of quadratic surfaces, which are cylinder, circle, ellipsoid, paraboloid, double cone, hyperbola of one sheet and two sheets. So, in this chapter, in this video, you will learn about general form of quadratic surfaces, and then you will learn how to plot all these kind of quadratic surfaces. General form of quadratic surfaces is given by this equation. If you see here, we have here variable of power 2. We have two variables are multiplied, and then we have here variable of power 1, and this one is constant. And there are many types of quadratic surfaces that can be put from this general form of equation. This involves elliptic cylinder. Okay, this one is cylinder. Elliptic paraboloid, which is actually in two dimensions, is from quadratic equation. Here, ellipsoid, cone, and also we have here hyperboloid. This one we call it hyperbola of one sheet, and this one is hyperbola of two sheets. We will learn some of these, how to draw in three-dimensional coordinate system. Now we go to the first quadratic surfaces, which is elliptic cylinder. We need to know the characteristic of elliptic cylinder. The first thing that we have to learn is about general equation of this cylinder. This cylinder is given by general form of x squared divided by a squared plus y squared divided by b squared equal to 1, which is a and b here are constant. From this kind of general form equation, you can sketch a cylinder. First, you can start in two-dimensional coordinate system, and then you can transform into three-dimensional coordinate system. Here is a sketch of a typical cylinder, which is given by this shape. But please be careful, because in two-dimensional coordinate system, this kind of equation is given by a circle. But in three-dimensional coordinate system, it is a cylinder. Let's learn how to sketch a cylinder. So now we go to this example 1. Example 1 asks us to graph x squared plus y squared equal to 4 in R2 and R3. So x squared plus y squared in R2 actually is given by x squared plus y squared equal to 2 squared. And these two we call it as radius. In this case, we can draw in two-dimensional coordinate system a circle. It is a circle with radius equal to 2. That is, here we have 2, negative 2 for y coordinate, 2, negative 2 for x coordinate. So we need to form a circle. Means that here our shape is given by this circle in two-dimensional coordinate system. Now we want to sketch a graph of x squared plus y squared equal to 4 in R3. If you still remember that in R2 we will have here a circle. Okay, this graph will form a circle with radius 2, negative 2, here 2, negative 2. If you see in this equation, there is no z. Means that in this case, c can take any value. How can we transform in three-dimensional coordinate system? Okay, let's draw here. We have a three-dimensional coordinate system where this one is x, this one is y axis, and here is z axis. So we still have a circle. For on xy plane, we still have a circle with radius 2. Means that now we have here 2, negative 2, negative 2, and 2. When we draw here, we will have a kind of circle. And On xy plane here, our z equal to 0. And we know there is no z in this equation, means that z can take any value. So you can form a circle going up and going down to z axis, which is parallel to z axis. Here, when z equal to 1, we can draw a circle, okay, which is origin at this one, but still with the same radius. Also, when z equal to 2, for example, we can draw another circle. Z equal to 3, we can draw another circle. And also, z equal to -1, we will have here another circle. You can draw it parallel to z axis for negative value of z. So when we connect all these, we will got this kind of cylinder in three-dimensional coordinate system. What I did here, okay, I start to draw a circle on xy plane, which is here z equal to 0. And then I draw a circle, another circle going up, okay, going up, which is parallel to z axis, and then going down, which is parallel to z axis. So here we can see this equation will form a cylinder in R3, which is in three-dimensional coordinate system. This question asks us to identify and sketch the surfaces of x squared plus z squared equal to 4. So the first thing that you need to do is you need to identify the surfaces first. So now we know we have a general form x squared divided by a squared plus y squared divided by b squared equal to 1. We can write this equation in this kind of general form, that is we have x squared plus z squared, which is now we have equal to 4. So therefore we can move to this side, means that we will have here x squared divided by 4 plus z squared divided by 4 equal to 1. Now, it is in this kind of general form, but its variable for y is changed to z. So we know this kind of equation will give us a cylinder. But here there is a missing variable, or we can say there is no y variable in this case, means that when we form a cylinder in R3, y value can take any value, or our cylinder will parallel to y axis. But before we go to R3, we can draw this one in R2. How to draw in R2? Now we need to change our y variable or y axis to z. So we will have here x and z axis, but the radius here still equal to 2 because this one is r squared. So in this case, 2 squared equal to 4. So we will have here radius of 2, means that 2, here -2, -2. When we draw, we still got a circle, but with radius 2. However, for this case now, our y-axis becomes z-axis. What I did here, I will got for this R2 or two-dimensional coordinate system a circle on x-z axis with radius 2. So if we transform x squared plus z squared in R3, we will have here one is x coordinate, z coordinate, and y coordinate. X, y. Now we know our x, we have a radius 2, here -2. Previously, we have at y coordinate 2, -2, but now we have x and z. So y can take any value, but for z coordinate, we have here radius 2 and -2. So when we connect all these, we'll got this kind of circle. And we can draw a circle which is parallel to y-axis. That is here, y can take any value. So I can draw this kind of circle, which is for the positive y, and then for the positive x, for the negative y, and then I can connect all these, means that I got here a cylinder that parallel to y-axis Means what I did here, when I go to this three-dimensional coordinate system, I draw a circle with radius 2, which is intersect at x and z axis at point 2, and then we can draw a parallel circle to y axis with the same radius. So we have this kind of circle, and also for negative y axis means that when we connect all this, it forms a cylinder that parallel to this y axis, means that y can take any value. We also can use GeoGebra to sketch a graph of example 1 and 2. For this example 2, when we sketch in GeoGebra, so you can see, you will get this kind of surface, which is a cylinder that is parallel to y axis.